Okay, if you're going to verify this formula, you're either going to take the derivative of this side to get over here, or you're going to integrate this side to go over here. This side is difficult, and you would only be led to do that because you read and speak English as opposed to, say, Arabic. I bet people who speak Arabic will be just as likely to go either way. Anyway, so let's take the derivative of the right-hand side and see if we get to the left-hand side. Obviously, the constant's going to disappear, so we don't care about that. How are we going to take the derivative? Well, there's more than one way of doing it. You could actually rewrite it as, you could bring the x inside if you want, but that's going to be a pain. Okay, so we're not going to do it that way. So let's just use either the quotient rule or the product rule. Okay, so I'm going to say f is minus x to the minus 1. So I'm going to put the denominator with the negative sign in the first piece. 1 plus x squared to the 1/2, and the plus c is going to go away. Again, there's different ways you can approach this. So the first times the derivative of the second okay, but in the course of taking the derivative of the second, I need the derivative of the fly, remember? Oh, there's the fly. Plus the derivative of the first, so this negative times this negative 1 is going to be positive, x to the negative 2 times 1 plus x squared to the 1/2. Okay? But normally I'd say, just stop, but you can't because you have to actually verify the formula. So this is one of the exceptions to the stop suggestion. Okay, so this 1/2 cancels with this 2. Now what? Let's see, we have 1 minus 1 over, let's see, x in the denominator, square root of 1 plus x squared in the denominator. What else do we have? We have x up top. Okay, so these x's cancel out. Alright, now we've gone to the next term. 1 plus x squared, and the square root, and then x. Yes, that's what it looks like. At which point you conclude you've done everything wrong, and you give up, and you get all discouraged. No, that's not what you do. You look at it and you say, okay, let's say maybe I did everything wrong, but is my structure correct? Yes. So double check everything you did, and it looks pretty good. So then you think, well, hopefully I'll get some partial credit, but if not, let's at least try to simplify this a little bit. Okay, what I mean by simplify is, of course, make it more complicated. That's what mathematicians always mean. Just kidding. Okay, but what are we going to do? We want common denominators, right? Of course we want common denominators. What do you think? But this is extra special because not only do we get common denominators out of the deal, we're going to get rid of some nastiness up in the numerator, which is what we were hoping for, getting rid of it. Aha. Yay! Happy face. Or maybe more traditional, you'd be putting a little box in an RAA, or just a check mark. RAA is more in geometry. You don't typically do that here. But that's perfectly good. That's enough.